Hello everybody, my name is Bailey Henderson and today I will be completing my statistics project on U.S. National Park deaths from 2007 to 2018. National parks are a wonderful way to see the United States. I highly recommend it. You can kayak, you can backpack, canyoneer, there's so much to do. It's one of my favorite things to do. I travel as much as I can. But many people don't know that national parks have a high death rate, and many people from all ages experience death while just trying to go on vacation. So I set out to research exactly how many of these deaths happen, and if it is younger people or older people or somewhere in between. I know this topic might seem a little dark, but the inspiration kind of just came from my love for U.S. national parks, and it just got my curiosity going. This data was obtained from Panacea and Boyle LLP website and Far and Wide website with some help from Statista.com. So a simple data set or sample of 7 different ages were obtained by decade. I wanted to see what age had the highest deaths while visiting the national parks. The explanatory variable is the ages by decade because it is the cause. And then the response variable is the number of deaths because it is the effect. The number of deaths and ages were entered in a spreadsheet, and I tested the hypothesis to see what age had the highest deaths. So as you can see, for age 10, we have 35 deaths. For age 20s, 360. In the 30 range, we have 332. 40, 298 deaths. 50, 365 deaths, 60s, 388, and in age 70s, 288. Now, obviously, there can be some lurking variables while collecting this data. For example, one could be wanting to take into consideration what was the cause of death. Should we use an age range instead of just by decade? And were they male or female? Excuse me, what national park was it? Some national parks have a higher death rate, but I'm just taking it as a whole. And were they under the influence or not? Drinking, drugs, all of that. There are many reasons why maybe an age group is higher than the other, but we're just taking a simple data set of 7. So to find the linear correlation coefficient, and determination of the data set, I used my TI-84 calculator. I'm not going to go over those steps with you because I'm sure we're all doing that. But what I found was R equals 0.5423 and R squared is 0.2940, and that equals out to 29.4% for R squared. So now determine if a linear relation exists. I determine my absolute value of 0.5423. Then I will use table 2 from Appendix A in my statistics book to determine the critical value. So n equals 7 because there are 7 data points. So the critical value for that is 0.754. Therefore, since 0.5423 is less than 0.754, this is a negative linear relationship and exists between age of death and death in the U.S. national parks. Now to find the least squared regression, I'll also use my TI-84 calculator, and what I end up getting is y hat equals 3.0214 plus x plus 174.4286. And then I got curious, what if age was not every decade? What if it was a specific number, like a 43-year-old? So to find the deaths for the age, let's say 43, I calculated 3.0214 and then times 43 plus 174.4286, which equaled out to about 304 deaths for the age of 43-year-olds. And you can do this with any other age and you'll calculate the exact deaths of U.S. national parks of that specific age. So if someone is in a national park and for every 1 year they get older, the expected death rate for the person will increase by 3.0214. There is a possibility that there could be 0 deaths, but only if the X value has the age of 0. We do not need to interpret the y-intercept because the X values are between 10 and 70. Next, I wanted to test for a linear relation at 95% confidence with an A equals 0.05 level of significance. So I have my null hypothesis and I have my alternative hypothesis. And then I also have my 95% confidence level with my level of significance of A equals 0.05. So when I put that into my calculator, I won't go over those steps with you, but I come out with T equals 1.443. The p-value is 0.2086. The degree of freedom is 5, and the standard deviation is 110.79. So in conclusion with that, because p-value is 0.2086 is greater than the level of significance at A equals 0.05, I will not reject my null hypothesis. There is not sufficient evidence at the A equals 0.05 level of significance to conclude that a linear relation does not exist between the age and deaths in the U.S. national parks. Next, I will just show you my scatter plot. And then my residual. You can see down here, I'm sorry, it's a little light, but all the way down here we have about -175 and then -100, and then the rest are up here. The rest of the 5 are up here. I have my x-axis, my y-axis, deaths, and age. And then in conclusion, I am 95% confident that there is a difference in how old someone is relating to deaths in U.S. national parks. After what I found, I do believe there is a higher population that would need to be studied to determine what and why the deaths are occurring at these ages. I only observed the ages for every decade, whereas I did not take into consideration whether they were male, female, intoxicated, tired, what time of day it was, and the cause of death, which I believe is the #1 factor. So clearly, age 60 has the greatest number of deaths in U.S. national parks. Thank you guys so much.